Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will take a look at a homework from section 6.4. It says the assets in billions of dollars of four wealthiest people in a particular country are 47, 32, 16, and 12. Assume that samples of size n is equal to 2 are randomly selected with replacement from this population of four values. And then they want us to identify 16 possible samples of size 2, and then find the mean for each sample, and then construct the table representing the sampling distribution. So let's get these numbers down: 47, 32, 16, and 12. That's 47, 32, 16, and 12. Just to make sure, 47, 32, 16, and 12. Okay. There are 16 possible combinations of them. So I will move these numbers over and I will use this as a reference to complete the 16 of them. And I will start with 47. So combination of 47, and then I put that number back. I could possibly get 47 again. I can get 47, and then my next number could be 32. I can get 47, and then my next number could be 16. I can get 47, and then my next number could be 12. And those are all the possible combinations when I select 47 first. Next is 32. I can select 32 and have a possible number of combinations with 47, 32, 16, and 12. And then I can select 16 4 times as my first value, and then the combination of those other values, and then finally 12, and then the combination of those other values for the second. So these are my numbers, and then now I want to find the mean of each of these pairs of numbers. So these are all my possible samples, and I want to find the mean of that. So that's the average of those two numbers. And the average of the first one is 47 because they're the exact same numbers, and then the average will vary as you go along. So now the question is, for each of these numbers or each of these averages, do any of them repeat? Because we want to find out the number of times that each of them repeats. 47 does not repeat, so that's only going to happen one out of the total number of times that it happens, which is 16. 39.5, does that repeat anywhere? That looks like it repeats over here. So that's going to be 2 out of 16 that this could possibly happen. So let's just do a quick highlight here. That'll be 2 out of 16. I guess that would simplify to 1/8. I have 31.5, and that happens here again. So this looks like it's going to happen twice. 29.5. Does that happen anywhere else? It happens somewhere else. If you can see a pattern, it looks like most of these things will happen twice. Except when we get to the next one, 32. Does that look like it happens again? And the answer is no. This doesn't happen again because the two numbers that we have are both 32, and so the average is going to be 32. So it looks like most of the things will happen twice, except for these numbers that are exactly those numbers in our population. So everything else, like 24, should happen twice, 22 should happen twice, and 14 should happen twice. Alright, so it looks like we have some sort of idea on how to fill out this table rather quickly instead of tediously going through these numbers. Our original numbers from our population is 47, 32, 16, and 12, and each of those would just happen 1 out of 16. So when I get to the next number that does not happen twice, it's 32, 1 out of 16 again. It's the number 16, 1 out of 16, and the number 12, 1 out of 16. Everything else happens twice, and we can call that 2 out of 16, or it simplifies to 1/8. So this average will happen twice, 1/8, and then everything else will be also 1/8. I think we missed one up here, missed 2 up here. They all have their probabilities. Let's check our answer. Okay, that looks good. It says compare the mean of the population with the mean of the sampling distribution. So the mean of the population, we never figured that out, but let's figure it out right now. The mean of the population is going to be the average of these numbers, and that's 26.75. So the mean of the population is 26.75, and we want to find the mean of the samples. So these are samples. Let's find the average of all these numbers. 26.75. So it looks like the means are equal to each other. This looks like it's going to be a good sign. The sample means target the population mean. And in general, do the sample means make a good estimate for the population mean? So the sample means do target the population mean. In general, sample means do make a good estimate for the population means, because the mean is an unbiased estimator, because it's equal. And it doesn't matter how it's set up, we're going to get those things to equal each other. All right. I hope that helps.